Hi, we are going to start 6.8. Before that, I'm going to present my screen. Yes, here is the L'Hopital's rule. The L'Hopital's rule works like this. We know that the first step in evaluating limit x approaches a fx is substitute x is equal to a in fx. And when we substitute, if you get a finite number, then that number is the limit. That means if the result is a finite number, then that number is the limit. If the result is 0 over 0 or infinity over infinity, then we may apply L'Hopital's rule. These two are called indeterminate. 0 over a non-zero number is 0. Any non-zero number divided by 0 is undefined, but 0 divided by 0 is called indeterminate. So this also, infinity over infinity also is indeterminate. So when you substitute x is equal to a, if you get a 0 over 0 or infinity over infinity, then L'Hopital's rule is a very efficient tool to evaluate the limit. So what you have to do is you rewrite, if necessary, you rewrite the function as fx over gx, limit x approaches a, fx over gx, substitute x is equal to a. If you get a 0 over 0, you may use the L'Hopital's rule. You write equal to and above that write h. That tells you, or that tells the reader that you are applying the L'Hopital's rule. Limit x approaches a, f prime x over g prime x. That means you differentiate fx and gx separately. Don't use the quotient rule. Differentiate fx, differentiate gx, and then substitute x is equal to a. If again it is 0 over 0 or infinity over infinity, then you differentiate again numerator and denominator. You repeat this procedure until you get an answer that is not indeterminate. So this is the procedure. The following are indeterminate: 0 over 0, infinity over infinity, 0 times infinity, infinity to the power of 0, 1 to the power of infinity, infinity minus infinity. These are indeterminates, but L'Hopital's rule is applicable only when it is either 0 over 0 or infinity over infinity. For example, evaluate limit x approaches 0, sin x over x. When you substitute x is equal to 0, sin 0 over 0, sin 0 is 0. So that is 0 over 0. You differentiate numerator and denominator separately. Limit x approaches 0, derivative of sin x is cos x, derivative of x is 1. Then you substitute x is equal to 0, you get cos 0 over 1, and cos 0 is 1. So the final answer is 1. Example 2. Evaluate limit x approaches infinity, e to the power of x divided by x square. Limit x approaches infinity, e to the power of x divided by x square. Yes, substitute the limit. E to the power of infinity is infinity. Infinity square is infinity. So when you substitute x is equal to infinity, you get infinity over infinity. So you can apply the L'Hopital's rule. So limit x approaches infinity, differentiate the numerator, e to the power of x, differentiate the denominator, 2x, derivative of x square is 2x. So again, substitute x is equal to infinity, you get infinity over infinity again, differentiate once again, differentiate numerator, you get e to the x, differentiate the denominator, you get a 2. So when you substitute, you get e to the power of infinity over 2, which is infinity. E to the infinity is infinity. This is a question from the textbook. Question number 8. Limit x approaches 3, x square minus 9. Sorry, x minus 3 divided by x square minus 9. Yes, actually substitute. When x is equal to 3, numerator is 3 minus 3, which is 0. Denominator is 3 square minus 9, that is 9 minus 9, again 0. Now apply L'Hopital's rule. Derivative of the numerator is 1. Derivative of the denominator is 2x. Substitute x is equal to 3. 1 divided by 2 times 3, the answer is 1 over 6. Number 10. Limit x approaches negative to x cubed plus 8 divided by x plus 8. Substitute x is equal to negative 2. Negative 2 the whole cube is negative 8 plus 8, that is 0. Denominator negative 2 plus 2, that is 0. So you may apply the L'Hopital's rule. To differentiate the numerator, you get 3x square. Differentiate the denominator, you get 1. So substitute x is equal to negative 2. You get 3 times negative 2 the whole square, which is 4 3s are 12. Number 12. Limit x approaches 1/2, 6x square plus 5x minus 4, all divided by 4x square plus 16x minus 9. Substitute x is equal to 1/2. You may substitute and see. I did not show the step there, so I'm going to show the step. Let me put the calculator here. We are going to substitute x is equal to 1/2. So I'm going to show you a method, an easy way to substitute. What you have to do is enter 1/2. You store it in x. And now we are going to work out the numerator. Numerator is 6x square. 6x square plus 5x minus 4. 0. So numerator is 0. Similarly, the denominator 4x square plus 16x minus 9. 0. So that is 0 over 0. And now apply the L'Hopital's rule. You differentiate the numerator. 6 times 2x, that is 12x, plus 5 denominator. 4 times 2x, 8x, plus 12, plus 16. So when you substitute the x is equal to 1/2, numerator is 12 times 1/2, which is 6. 6 plus 5 is 11. Denominator 8 times 1/2, that is 4. 4 plus 16 is equal to 20. So the answer is 11 over 20. Number 14. Limit x approaches 0, tan 3x divided by sin 2x. When you substitute x is equal to 0, tan 0 is 0, sine 0 is 0. So it is 0 over 0. Now apply the L'Hopital's rule. Limit x approaches 0. Derivative of tan 3x, secant square 3x times 3. So it is 3 secant square 3x. Denominator cos 2x times 2. Now substitute x is equal to 0. Secant square 0 is 1 because cos 0 is 1. Denominator cos 2 times 0, that is cos 0 is 1. So it is 3 over 2 times 1. So that is the answer. Number 16. Limit x approaches 0. X squared divided by 1 minus cos x. Numerator is 0 squared, that is 0. Denominator is 1 minus cos 0. Cos 0 is 1. So 1 minus 1 is 0. So it is 0 over 0. So apply the L'Hopital's rule. Limit x approaches 0. Numerator 2x. Denominator is sin x. There is a small mistake here. The derivative is wrong here. I messed it up. So it is actually a plus sin x. It's not a minus sin x. It is a plus sin x. Please note that. So 2x divided by sin x. That is 0 over 0 again. So that is again 0 over 0. You differentiate. 2 divided by cos x, because this is a plus sin x. 2 divided by cos x, and that is equal to 2 divided by 1. Cos 0 is 1. So the answer is not negative 2. Answer is positive 2. Please correct that mistake. Sorry about that mistake. And let us check whether the answer is right or not. I believe the answer is positive 2. So this is one way to check your answer. Keep the calculator in radian mode, and then you graph that function. X squared divided by x squared divided by 1 minus cos x. Yes, so see, it is here. It is 2, positive 2. Please correct it. Here is the mistake. Negative cos x, when you differentiate negative cos x, you get positive sin x, and that positive sin x becomes positive cos x. So it is 2 divided by 1, which is 2. Number 18. Limit theta approaches pi, 1 plus cos theta divided by 1 minus cos theta. So then substitute. Cos pi is negative 1. So this is 1 plus negative 1, which is 0. Denominator 1 minus negative 1, that is 2. So limit, you don't need a L'Hopital here because the limit is a finite number. So the limit is 0. Number 20. Limit x approaches infinity. X plus x square divided by 1 minus 2x square. When you substitute infinity, you get infinity plus infinity square, that is infinity. Denominator 1 minus 2x square, that is negative infinity. Now differentiate. Numerator 1 plus 2x, denominator negative 4x. Again you get infinity over negative infinity. Now again differentiate. 2 divided by negative 4, which is negative 1/2. I did not write the negative sign here. You don't have to. Number 22. Limit x approaches infinity. Natural log of square root of x divided by x squared. A property of logarithm. If there is an exponent, that exponent comes to the front, and natural log of square root of x is natural log of x to the 1/2 1/2 comes to the front, so that is 1/2 times natural log of x. So this is 1/2 times natural log of x divided by x square. Natural log of infinity is infinity, divided by infinity square. Again, apply the L'Hopital's rule. Limit x approaches infinity, 1/2 times derivative of natural log of x is 1 over x. Derivative of x square is 2x. So that is equal to limit x approaches infinity 4x square, which is 1 over infinity. Answer is 0. (24) Limit t approaches 0, 8 to the power of t minus 5 to the power of t divided by t. So substitute t is equal to 0, numerator, 8 to the 0, 1, 5 to the 0, 1. So 1 minus 1 is 0. Denominator is 0. So you may apply the L'Hopital's rule. Differentiate the numerator. Derivative of 8 to the power of t is 8 to the power of t times natural log of 8 minus derivative of 5 to the power of t is 5 to the power of t times natural log of 5, or divided by 1. Now substitute t is equal to 0. 8 to the 0 is 1, so it is natural log of 8 minus natural log of 5, because 8 to the 0 is 1, 5 to the 0 is also 1. Number 26. Limit u approaches infinity, e to the u over 10 divided by u cubed. Substitute u is equal to infinity, you get e to the infinity divided by infinity cube, so that is infinity over infinity. Differentiate, limit x u approaches infinity, e to the u over 10 times 1 over 10, that's the numerator, divided by 3u square. Again, infinity over infinity. Then again differentiate the numerator, e to the u over 10 times 1 over 10. Already there is a 1 over 10, so that is going to be 1 over 100 over 6u, that is infinity over infinity. Again, differentiate once again, that is e to the u over 10 times 1 over 1000 or divided by 6. Now substitute u is equal to infinity. You have infinity divided by 6000, which is infinity. Number 28. Limit x approaches 0, sin hx minus x divided by x cubed. Numerator, sin h0 is 0. So 0 minus 0, numerator is 0. Denominator, x cubed, 0 cubed is 0. So it is 0 over 0. You may use the L'Hopital's rule. Derivative of sin hx is cos hx. Derivative of x is 1. So numerator is cos hx minus 1. Denominator is 3x square. Derivative of x cubed is 3x square. That is equal to 0 over 0 again, because cos h0 is 1. 1 minus 1 is 0. Differentiate once again. Derivative of cos hx is sin hx divided by 6x. Again 0 over 0. Differentiate once again. Cos hx divided by 6, which is 1 over 6, because cos h0 is equal to 6. Number 30. Limit x approaches 0, x minus sin x divided by x minus tan x. Substitute x is equal to 0. You get 0 minus sin 0, which is 0. Denominator. 0 minus tan 0, that is 0. Differentiate numerator. You get 1 minus cos x divided by 1 minus secant square x. Cos 0 is 0. Secant 0. Cos 0 is 1. Secant 0 also is 1. So numerator 1 minus 1, which is 0. Denominator 1 minus 1, again 0. Differentiate once again. Numerator sin x, negative of negative sin x, that is sin x, denominator. First you apply the chain rule, negative power rule, that is negative 2 secant x. Then derivative of secant x is secant x times tan x, that is sin x, divided by negative 2 secant square x. I replace tan x by sin x over cos x. So cos x goes to the numerator. And so this is sin x over negative 2 secant square x times cos x over sin x. And 1 sin x cancels. So it is cos x divided by negative 2 secant square x. And so that is 1 divided by negative 2. Answer is negative 1/2. Yeah, you have to apply the L'Hopital several times here. Number 32. Limit x approaches infinity. Natural log of x the whole square, whole divided by x. Natural log of infinity is infinity. So it is infinity square over infinity, which is infinity over infinity. Apply L'Hopital's rule. Numerator, derivative is 2 natural log of x times 1 over x, whole divided by 1. And so that is the same as 2 natural log of x divided by x, which is again infinity over infinity. Differentiate once again. You get 2 over 2 times 1 over x, which is 2 over x, divided by 1, which is 2 over infinity, which is 0. 2 over infinity is 0. 34. Limit x approaches 0 plus x to the x minus 1 divided by natural log of x plus x minus 1. So numerator is 0 minus 1 divided by, let me check it, I doubt whether. I think that question is not complete. I used a calculator to get this number. Gx, that's negative infinity, so I will show you how to use it. Y is equal to x to the x minus 1. Yeah, when x is equal to 0, it is approximately 0. And denominator is natural log of infinity, which is negative infinity. So the answer is 0. So I calculated this 0 by using the calculator, but there is a way to get it. That means you call this expression x to the x as z, then find the natural log of z, and after a few steps you get the answer. But you don't have to worry about that. In this case, I calculated the numerator value as a 0 by using the calculator. Denominator is infinity, so that's it. Number 40. Limit x approaches 0, e to the x minus e to the negative x minus 2x divided by x minus sin x. When you substitute x is equal to 0, e to the 0 is 1 minus e to the negative 0, that is again a 1. So 1 minus 1 minus 0, which is 0. Denominator 0 minus sin 0, that is 0 minus 0, which is 0. Now differentiate numerator, you get e to the x plus e to the negative x minus 2 divided by 1 minus cos x, that is e to the 0 plus e to the negative 0, which is 1 plus 1, 2 minus 2, numerator is 0. Denominator 1 minus cos 0 is 1. So that is 0 over 0 again. Differentiate once again. E to the x minus e to the negative x divided by sin x, and substitute x is equal to 0, e to the 0 minus e to the negative 0, that is a 1 minus 1, 0, divided by sin x, so sin 0, that is 0 over 0, again differentiate e to the x plus e to the negative x divided by cos x, and the answer is 2 over 1, which is 2. If you want, you may check your answer by using the calculator. (44) Limit x approaches infinity, square root of x times e to the negative x over 2. When you substitute x is equal to infinity, you get infinity times 0. You cannot apply L'Hopital's directly. So we must rewrite the function as a ratio of two functions, fx over gx. So square root of x is x to the 1 half, e to the negative x over 2 is 1 over x over 2. So I wrote it as x to the 1 half divided by e to the x over 2. Substitute, you are going to get ex to the infinity over infinity. Now apply the L'Hopital's rule. You get 1 half x to the negative 1 half divided by e to the x over 2 times 1 half cancels. You get limit x approaches infinity, 1 over square root of x times e to the x over 2, and that is 1 over infinity, answer is 0. 46. X times natural log of 1 minus 1 over x. X approaches negative infinity. X times natural log of 1 minus 1 over x. So 1 over negative infinity is 0. So it becomes x negative infinity times natural log of 1, which is 0. So negative infinity times 0, you have to rewrite it. So I decided to write it like this. I kept natural log of 1 minus 1 over x in the numerator, and x is written as 1 divided by 1 over x. So multiplication by x is the same as division by 1 over x. And now I did the differentiation in 2 steps. So fx is natural log of 1 minus 1 over x. So f prime x is 1 over 1 minus 1 over x times negative of negative 1 over x square. I repeat, I called the numerator as fx, and then I differentiate that. You get natural log of x, derivative is 1 over x. So in this case, it is 1 over 1 minus 1 over x times this negative sign stays there. Then derivative of 1 over x is negative 1 over x square. Simplify, you have 1 over x square divided by 1 minus 1 over x. That is 1 over 1 minus 1 over x times x square. Okay, now use the L'Hopital's. So this is equal to limit x approaches infinity, 1 over 1 minus 1 over x times x square, that is the numerator, divided by the derivative of 1 over x, that is negative 1 over x square. And now rewrite it as a multiplication. So it becomes limit x approaches infinity, negative x square divided by division by 1 over x square is the same as multiplication by x square over 1. So negative x square divided by 1 minus 1 over x times x square cancels. You get negative 1 over 1 because x approaches negative infinity. Again, I did a mistake here. I wrote plus infinity. It is negative infinity. So you have to replace this infinity by a negative infinity, this infinity by a negative infinity, this infinity by a negative infinity. So the final answer is x is equal to negative 1. Let me check the answer. X times natural log of 1 minus 1 over x. Yeah, it is negative 1. It is, what was the answer? Yeah, it is negative 1. See here, as x approaches negative infinity, value of y is negative 1. Number 48. Limit x approaches infinity, x over x to the power of 3 half times sine 1 over x. Again, you have to apply a technique here. You call 1 over x as theta. So let 1 over x is equal to theta. So x is equal to 1 over theta. And as x approaches infinity, theta approaches 1 over infinity, which is 0. I repeat, when you see a 1 over x under sine, as the argument of sine, this is a good idea. You do a substitution. You might have seen this in Calc 1. 1 over x is equal to theta. So theta is equal to 1 over x. X is equal to 1 over theta. As x approaches infinity, theta approaches 1 over infinity, which is 0. And so it becomes limit theta approaches 0, 1 over theta whole to the 3 half times sine theta. That is limit theta approaches 0, sine theta divided by theta to the 3 half. Sine 0 is 0, theta is 0, so it is 0 over 0. Apply the L'Hopital's rule. Derivative of sine theta is cos theta divided by 3 half theta to the 1 half power rule. And so substitute theta is equal to 0. You get 1 divided by 3 half times square root of 0, that is infinity. Final answer is infinity because denominator is 0, numerator is not 0. This is a positive 0 because square root means the answer is positive. So it is, answer is positive infinity. Number 50, limit x approaches pi over 2 minus cos x times secant 5x. Secant 5x is 1 over cos 5x. So rewrite it. Limit x approaches pi over 2 minus cos x divided by cos 5x. Cos 0 is cos pi over 2 is 0. So this is 0 over 0. Cos 5 pi over 2 also is 0. Then limit x approaches pi over 2 minus, you are using the L'Hopital's rule. Numerator minus sin x, denominator minus 5 sin 5x. Substitute x is equal to pi over 2. You get minus sin pi over 2, which is 1. Denominator minus sin 5 pi over 2. That also is 1. And so 5, negative 5 times 1. So the final answer is 1 over 5. If you are not sure about sine 5 pi over 2, you can use the calculator. Keep the calculator in radian mode. Sine 5 pi over 2 1. So that is negative 5 times 1. So the answer is 1 over 5. Number 52. Limit x approaches 0. Cosecant x minus cot x. Cosecant 0 is infinity because sine 0 is 0. So that is 1 over 0, infinity minus infinity. So rewrite it as 1 minus 1 over sine x minus cos x over sine x. This is 1 minus cos x divided by sine x. Again, that is 0 over 0. Now you use the L'Hopital's rule. That is, derivative of the numerator is sine x. Derivative of the denominator is cos x. So sine 0 is 0. Cos 0 is 1. So 0 over 1, the answer is 0. Okay, that is the end of 6.8, and your test is going to be based on section 1 through 8. So again, I'm going to post one more for this week because there are 4 days. So your test is up to 6.8. I will post 7.1 also, but the test is based on only chapter 6.